Hi everyone, this is your math guru. In this video, I'm going to show you how to solve the following trigonometric equation with the use of a cast diagram. In the first example, we have if 5 cos A plus 3 equals to 0 and 180 degrees is less than A is less than 360 degrees, determine by means of a diagram 1 tan squared A and 2 sine A over cos A. Before we pick or fulfill the two conditions given, we're going to start by finding what the value of cos A is. We have 5 cos A plus 3 equals to 0. Making cos A subject to formula, we have 5 cos A equals to negative 3. Then I have cos A equals to negative 3 over 5, dividing both sides by 5. The second condition says A is greater than 180 or less than 360. Because we have to use a diagram, that's the cast diagram, I'm going to go ahead and draw my cast diagram, labeling each quadrant. I have the first quadrant where all the trig functions are positive. We have the second quadrant where only sine is positive. We have the third quadrant, only tan is positive, and the fourth quadrant where we have only cosine positive. Now, to determine where our terminal arm will be, the first condition says cos A equals negative 3 over 5. If you go back to our cast diagram, we need to figure out where we have cos to be negative. In the first quadrant, cos is positive. In the second quadrant, only sine is positive, so we have cos to be positive in that quadrant. In the third quadrant, only tan is positive, so cos will be negative in that quadrant. In the fourth quadrant, cosine is positive, so we've been able to fulfill the first condition. The second condition, in order to fulfill that, I'm going to first of all label my Cartesian plane, starting with 0 degrees. Every quadrant is 90 degrees, so I have 0 plus 90, so that will be 90, plus another 90, that's 180, plus another 90, 270, and then back to 0 or 360 degrees. So therefore, if A is greater than 180, then that will fall in the two quadrant, that's the third and the fourth. Now, because we need to fulfill the conditions, the next step is to pick the quadrant that fulfills the two conditions given, and that will be the third quadrant. So a terminal end is going to fall in the third quadrant. That's where we're going to find angle A. And once we draw the terminal end, always roll towards your x-axis. So we have a 90 degrees as shown, and we have the angle to be A. The next step, labeling all the sides. Note that we have the positive x-axis and we have the negative x-axis. So because the value of cos A is negative 3 over 5, cosine using the trig ratio, I have the code SOHCAHTOA to help me in determining what the value of each ratio is. So we have SOHCAHTOA. Cos is adjacent over hypotenuse. So we have that as adjacent over hypotenuse. So determine which one is negative. We have the 3 in the negative x direction. So we have the adjacent to be negative 3. Note that the side facing the angle given, angle A, is at opposite, or the longest side is at hypotenuse, and the last side will be adjacent. I still call that A. Then we have cos to be adjacent over hypotenuse, so the hypotenuse will be equal to 5. That's the longest side. We are left with the value over opposite. To calculate the value of the opposite, we're going to use the Pythagoras theorem that states that the longest side, the square of the longest side, which is the hypotenuse, is equal to the sum of the square of the other two sides. So we have hypotenuse squared equals opposite squared plus adjacent squared. Hypotenuse is 5, so we have 5 squared equals, we are looking for our opposite, plus our adjacent, that's negative 3 all squared. 25, that's 5 times 5, equals opposite squared, plus negative 3 all squared, 9. Making our opposite the subject of formula, that's 25 minus 9, which is 16. And to find the value of our opposite, we're going to find the square root of both sides. So we have O plus or minus 4, that's the square root of 16. But because we have that in the negative y direction, therefore our opposite will be negative 4. So I'm going to put that in the diagram. Now going to the first part of the question that says, find the value of tan squared a. So we have the first question says, find tan squared a. Tan squared a is the same as tan a times tan a. And we know that tan is in our trig ratio. Tan a is opposite over adjacent, which is, if we go back to the diagram, opposite we got that as negative 4 over adjacent is negative 3. So that will be positive 4 over 3. So therefore tan squared a will be 4 over 3 times 4 over 3, which is equal to 16 over 9. The second part of the question, 2, says we're to find sine of angle A over the cosine of angle A. We know that sine is in the trig ratio. Sine is opposite over hypotenuse over hypotenuse. And if we go back to the diagram, our opposite is negative 4 over the hypotenuse is positive 5. We already found the value of cos A from the first part of the question, and that's negative 3 over 5. So therefore, if we slot that in, sine A divided by cos A will be equal to negative 4 over 5 divided by cos A, that's negative 3 over 5. Applying the fraction rule, that will be minus 4 over 5, the division changed to multiplication, of minus 5 over 3. Minus times minus positive. We have 5 and 5, 1, so therefore our answer will be 4 over 3. Let's look at the second part of the question. The part 2 says if 13 cos theta minus 5 equals to 0 and theta is greater than 180 but less than 360, determine by means of a diagram 1 sine squared theta plus cos squared theta and 2 25 tan squared theta. I'm going to start by simplifying the first part of the question that says 13 cos theta minus 5 equals to 0. Making cos theta the subject of formula, we have 13 cos theta equals to positive 5, so therefore cos theta equals 5 over 13, which is positive. Going back to our cast diagram, we need to determine which quadrant the terminal arm of our angle falls in. So starting from 0 degree, we have 90 degree. Every quarter is 90 degrees. And then we have 270 degrees. There's a cast diagram. So we have C, A, S, and T. That's a fourth quadrant, a first quadrant, second, and third. So to fulfill the first condition says cos theta is 5 over 13, which is a positive number. Where do we have cos to be positive? That's in the first quadrant. I'm going to put it thick there, and in the fourth quadrant. Then we need to fulfill the second condition. The second condition says theta must be greater than 180, but less than 360. We have that in the third quadrant and the fourth quadrant. Note that what this means is we have the two conditions fulfilled in the fourth quadrant. So that is where we're going to have an angle or a terminal arm in the fourth quadrant as shown. So labeling the sides, we have the angle as theta. Cos is adjacent using a trig ratio. We have SOHCAHTOA. I'm going to write it by the side. Cos is adjacent over hypotenuse. So we have 5/13 equals adjacent over the hypotenuse. If I label the sides of my triangle, the side facing theta is my opposite. The longest side is my hypotenuse. And the last side is my adjacent. So my adjacent will be positive 5. That's in the positive x direction. My hypotenuse is 13 as shown. And then we're left with our opposite. To find the opposite side, I'm going to use Pythagoras theorem that states that h squared, the longest side, equals my a squared plus o squared. That's the sum of the square of the other two sides. 13 squared equals a squared, that's 5 squared, plus o squared. Therefore, o squared equals 13 squared. I'm going to make o squared subject of formula. That's 169 minus 5 squared, 25, which is 144. Squaring both sides in order to find the value of our o. Then we have our o, or our opposite, equals square root of 144 is plus or minus 12. But because our o falls in the negative y direction, our o, or opposite, will be negative 12. So I'm going to write my negative 12. So we can go ahead and solve the questions attached. The first one says, 1, solve for sine squared theta plus cos squared theta. Sine theta, using our trig ratio, is opposite over hypotenuse. And using the diagram, opposite is negative 12. Hypotenuse is always positive, that's 13. Already, we have the value of cos theta. So putting in this value, sine squared, that's sine times sine, that will be minus 12 over 13 all squared, plus cos squared. We have cos from the first part of the question, that's 5 over 13 all squared. Simplifying further, we have that as 144 over 169 plus 5 squared is 25 over 169, because they are both the same denominator. Applying the fraction rule, 144 plus 25, that's 169. So therefore, sine squared theta plus cos squared theta equals to 1. Let's look at the second part that says, find 25 tan squared theta. We know that tan theta, using the trig ratio, is opposite over adjacent. Opposite in the question is negative 12, and adjacent is positive 5. So if I expand that, I have 25 times tan squared. I'm going to put that in the bracket, 12 over 5 all squared. That's equal to 25 times 144 over 25. And if I simplify, 25 and 25, 1. So therefore, 25 tan squared theta is equal to 144. Thanks for watching. Bye.